Hi everyone, welcome to Ken Matrix Online Academy, and I'm going to welcome everybody to this particular tutorial, especially O-level and A-level students. I am your online instructor, Ken Mwema, and the topic that we're going to discuss in this particular video tutorial is linear motion. So we are going to look at the following, this particular material. Number one, displacement time graph. We're going to have a sketch of a graph, an example. We are going to look at how we can get acceleration and how we can find the total displacement from the displacement time graph. We are going to look at one problem under that. The next is relative motion. We are going to see how bodies moving in opposite direction can how their velocities and their speeds can be determined. We are also going to see how the speeds and the times of bodies moving in the same direction can be determined as well. So let us go to our first problem. The question reads, the diagram below shows the speed time graph for a train traveling between two stations. The train starts from rest and accelerates uniformly for 150 seconds. It then travels at a constant speed of 300 seconds and finally decelerates uniformly for 200 seconds. Given that the distance between the two stations is 10,450 meters. Calculate the maximum speed in kilometer per hour the train attained. So let us first of all try to figure out this particular velocity time graph. Now, in most of the cases, the velocity time graph is normally given as velocity against time. In most of the time, it is velocity against time. But now in this case, it is speed. So let us just use this, whatever we are provided. Now, let us know the kind of motion properties, or rather, the motion that has taken place, step by step. Now, we're going to start with 150 seconds from rest. The first 150 seconds. In the first 150 seconds, the car moves from rest up to this point. From rest up to this point. From rest, it is from 0, when the velocity is 0, up to maximum speed that we have not been provided. It then travels at a constant speed of 300 seconds. So in the next 300 seconds, that is 300 seconds. In the next 300 seconds, it's going to have a constant speed. Constant speed means that it is not, the speed is constant. As you can see, from this point to this point, the speeds are constant. From that point to this point, the graph is neither going up nor going down. Now, another thing is, in the last 200 seconds, it decelerates, or rather, the speed comes down. It comes down from the uniform speed to from uniform speed to 0 speed, and that is the distance. That is the speed that it decelerates. In other words, deceleration means it is negative acceleration, whereby the speed is decreasing with the time. The the rate of increase in acceleration is negative. Now, so that is 200 seconds in the last 200 seconds. Now that we already have that in mind, we are going to look at the questions that will be asked. Given that the total distance between the two stations is 10,450 meters, calculate. Now, we have two diagrams here. We have three diagrams there. Number one, we have this triangle. Number two, we have this rectangle and another triangle there. So we ought to find, we all know, we should be able to know that distance is equal to total area in the velocity time graph is equal to the total area. So we have to find the area of this triangle plus the area of this rectangle plus the area of the other triangle for us to get the total distance. But remember that from here to here it is the velocity, and this is the maximum speed that we have not been provided. So we have to note that even before we go to the question. It is always important that before you go to attempt the questions, you get to figure out what aspect is missing, or what are you supposed to find that is not in the question, so that when you go to the question, you already asked yourself. So let us go to the question. Maximum speed in kilometer per hour the train achieved. So the question is asking this for this particular velocity. In other words, for this distance, for that distance there. And maybe we can call that distance h. Okay, we can call it h. Now let us go to the computations. Now we have seen we have how many diagrams? 3 diagrams, 2 triangles and 1 rectangle. But something to note again is that this we are going to calculate the area of these particular shapes by noting that h is the height of the triangles and h is also, maybe say, the width. The length of this, the base of the first triangle is 150. The length of the rectangle is 300, and the base of the second triangle is 200. So let us go to the solution. As we can see, this a half times 150h is the area of the first triangle, then a half times that is the area of the second triangle, and 300 times h is the area of the rectangle. Now maybe we can try to explain how it has happened. We all know that the area of a triangle is given by a half BH. So we have tried to treat 150, this 150 here, 150 as the base, and then the height the height is h. That is for the first triangle, the base is 150. The second triangle, the base is 200. Now how has 200 come in? 200 is as a result of saying 650 subtract 450. So it is this distance here, the distance, and therefore that is how we have been able to get 200. What about 300? The distance from here up to here. Now after knowing all that, we are good to go. But we must remember the total distance is 10,400. So the sum of these areas must be equated to 10,450. After doing all that, the next step is equating that. Now after equating that, we can now establish that 475H is equal to 10,450. And from that, it can be seen that the H is 22 meters per second. That is how we find the H, since the H is unknown. From the question, the speed is supposed to be presented in kilometers per hour. So how do we convert that particular speed to kilometer per hour? This is how the conversion should take place. We are going to multiply the whole thing by 3,600 over 1,000. So 3,600 divided by 1,000 times 22. In other words, now from the solutions in this particular slide, you can see they have just said 60 times 60, which is the same as 3,600. We all know that 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So 1 hour, one particular hour is equal to 60 times 60 seconds, for which that's why we are doing that. And we should be able to know that 1 kilometer is equal to 1,000 meters. That's why we are factoring in 3,600 over 1,000, then multiply by 200. If we were to do the reverse, converting a kilometer per hour to meter per second, you just reciprocate. You just say 1,000 over 3,600 times the speed. Okay, so that is how we do the conversion of speed from meters per second to kilometers per second. In other words, if we have to do it, maybe we want to convert meters per second to kilometer per hour, you say 1,000 over 3,600. And there, this is the answer. The answer is 79.2 kilometers per hour. That is the answer. So the next question is, calculate the distance traveled during the last 100 seconds. Back to the diagram. In the last 100 seconds. So remember that from here to here is 200. So where is 100 seconds line? We have to know where it is lying. 100 seconds is lying there between this point up to that point. So 100 seconds from here up to here. From this point up to this point, that is 100 seconds. Now in that 100 seconds, the velocity, still remember that the velocity will decrease by a factor. by which factor will the velocity decrease? So you look at that, you match. Basically it's going to be divided, the velocity will be reduced by a factor of 2, or let's say 22 divided by 2. Now that we have seen the velocity in meters per second, the maximum velocity is 22. So 22 is 22 here. This 22 here. Okay, so if the velocity is 22, we divide by 2 so as to get 11. So this is the speed of this particular. Now let me shade that area so that it can be recognized. So that is the small triangle. So back to the question. The question is asking the distance the train traveled during the last 100 seconds. So you can see we have this particular triangle. We have this triangle here. So we can consider the base as 100 seconds and the height as 11. Using that particular analogy, we can say the area is equal to a half times 100. Now that is the base and this is the height. Is equal to 550, because you're finding for distance, you're going to say in meters. 550 meters. On to the next particular part of this problem. Find the time train takes to travel the first half of the journey. The first half of the journey. Let us go back to the diagram. Half of the journey. So half of the journey. Where is the half of the journey lying? We have to know that where the half of the journey is lying. The half of the journey is lying here. The whole of that, let me share that. The whole of that is the half of the journey. Now, the biggest question is, we already have known how this is coming up. We already know the properties of this particular triangle. The next is this rectangle. We don't know. Let us say the distance from here up to here is t, because we are talking about the horizontal distance. So the horizontal distance is given by t, because the x-axis is time. Figuring out, after looking at that way, since this is a rectangle, when the rectangle combines with this particular triangle, it becomes a trapezium. So that right below there, the distance is 150 plus t. 150 plus t. Right below there it is 150 plus t. So that becomes a trapezium. You're going to use a half AB plus half AB plus half A plus B times height. Now let us go to the solution and see what is happening. Now remember that, just note this before we go to the solutions. This will be our A, and this, all of this will be our B, and our height is going to be 22. And then after that, we equate it to half the total distance, because the total distance, you are going to take the total distance divided by 2. So we equate the two. So let us see how it's going to happen in the solution. So that is it. There we are. Is equal to half a plus b times h. Now let me highlight that. Now we have said that you are going to use the formula of the trapezium. Let that be a, and let this single t be b. So the area of a trapezium is half a plus b, maybe, times h. Our h is already 22. This is our h, this is our a, and this is our b. And as I had said earlier, we have to equate it with a half of the total distance. Why are we saying a half the total distance? Because the question is already asking about the half the journey. So we have to equate it with a half the total distance. So this is how it has been equated. Remember, just note, the main idea here is to find out the value of t. Now after doing all that particular manipulation, we find out that the value of t is 162.5 seconds. 162.5 seconds. But what is the total time? Let us go back to the diagram. We are asked the total time. This is the time. This is the time from here up to here. The total time is 150 plus t, not t. The total time is 150 plus t. From 0 seconds to 150 plus t. So what is the total time? The total time is 150 plus this t, 162.5, and that becomes 312.5 seconds. So that is all about the velocity time graph. And if I can sum it up in that particular section, I can say we all normally, for us to get the distance, we have to find the area under the graph, and the height is normally given by the velocity or the speed, and the time, normally it is either the bases or the length of rectangles and triangles. So on to the second example. The second example is on linear motion, and here we are going to see a question relating to particular bodies. A motorcycle is the question. A motorcycle travels at 10 kilometers per hour. 10 kilometers. This is 10. Correction, that should be 10 kilometers per hour faster than motorbike B, whose speed is x kilometers per hour. Motorbike A takes 1.5 hours less than motorbike B to cover 180 kilometers journey. Write an expression in terms of x for the time taken to cover 180 kilometers journey by motorbike A. So the speed of motorbike B is x kilometers per hour. We are told that A takes 10 kilometers, travels 10 kilometers per hour faster than B. So having noted that, and motorbike A takes 1.5 hours less than motorbike B. So that is the expression. This is the expression for the speed taken by motorbike A. The expression is 180. Now how has this come about? We should know that since speed is equal to distance over time, then the time can be calculated as distance over speed. In this case, the distance is 180 and the time taken by motorbike A is x plus 10. Why are we saying x plus 10? Because we are told in the question that it travels 10 kilometers per hour. Note there is a correction here. It should be 10 kilometers per hour faster. So it is x plus 10. X plus 10. That's why we are saying x plus 10 for A. Now let us go to B. For B, since the speed of B is just x, this is the speed of B, it is simply 180 over B. In fact, this particular speed of B should have been solved earlier than the speed of A. But either way, nevertheless, we can just continue with our computations. Let us go to the next section. Next section is use the expression in A above to determine the speed in kilometer per hour of the motorbike A. Now, back to the question. We note what we need to see what is the information provided there. The question is asking let us go to the second statement. Let us look at the second statement. Motorbike A takes 1.5 hours less than motorbike B to cover 180 kilometer journey. So it is the difference in times. Okay, let us say this is a time motorbike A takes less, time 1. Okay, this is time 1, or let me call it time A. The time taken by motorcycle B, and then let us call this time B, the time taken by B, so that the difference in their times will result to 1.5 hours. But who takes more time than the other? We have to know that since A takes 1.5 less, a motorcycle B will take more time than motorcycle A. So in other words, it is safe for us to say TB minus TA is equal to 1.5. 1.5 converted into improper fraction is just equal to 3/2. Now, after figuring out that, we go back to the solution. So, in the solution that has been provided, this is our TB, and this is our TA. When you equate the two together, you find 3/2. once again, let me illustrate it once again. This is our TB. This is our TA, that when you get the difference, you find out as 3/2. Now, doing the manipulation, of which we are going to multiply by 2 both sides, by 2, by 2, by 2, cancel the 2's, okay? After multiplying by 2 and cancelling the 2's, the next thing you're going to do is multiply by x plus 10 both sides. Both sides, x plus 10. X plus 10 both sides. Like it has been done here. X plus 10 both sides. Okay. And also multiply by x again. Multiply by x. To remove this x plus 10s and x, you have to multiply like it has been done here. Or rather, to simplify the process, we just multiply x plus 10 here and x plus 10 here. They should not be multiplied because it has already have x plus 10 as the denominator. Then you multiply by x where we don't have x. Here x has already cancelled out, so multiply by x. There is no x. You can see there is no x. What you have is x plus 10. Here we don't have x plus 10. It is x. And then here it has both x and x plus 10. Now opening the brackets, it leads to a quadratic equation. Now, the purpose of this lesson was not to teach quadratic equations, but I'll prepare another video on quadratic equations. Solving this quadratic equation can either use elimination, completing the square method, or you can use quadratic formula. Maybe the easiest way is quadratic formula. Let me just put a reminder for those who might have forgotten quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now, what will be if this is the quadratic equation, our b will be 10, our c will be minus 1200, our a will be the coefficient of x squared, which is 1. Then you substitute those values in the quadratic formula. That is, you're going to get two values of x. First one is 30, the second one is minus 40. But in our case, now that we are finding for the speeds, what are we going to do? The speed x is the speed of b. It should not be negative, so we're going to pick this 30, the positive. The speed cannot be negative. This is the speed of b. The speed of a is 30 plus 10, because we said in the question, maybe I can take you back to the question. Motorbike A travel at 10 km faster. So A is 10 km faster than B, so that A is x plus 10 kilometers faster than B. So that is what has happened, and that is the reason as to why the speed of A is 30 plus 10, which is 40 meters or is it given in kilometers in the question? Let us confirm whether in the question it is given. Yeah, it is given in kilometers per hour. We don't need to convert. So kilometer per hour. So let us go to this next part of this question. For a journey of 48 kilometers, motorbike B starts 10 minutes ahead of motorbike A. Calculate in minutes the difference in times of their arrival at the destination. Calculate in minutes. So we have to note that in minutes. The difference in their time, in the arrival of their destination. So motorbike B starts 10 kilometers, so it is 10 minutes ahead. So it is ahead of time by 10 minutes. Now the first time taken by A is 48 kilometers divided by 40 minutes. But you have to convert these minutes into is 40 times 60. Now, why are we saying that? Why are we multiplying that way? Let us go back to the previous solutions. The speed of A is 40 kilometers per hour. 40 kilometers per hour. So if the speed is in 40 kilometers per hour, we have and the distance is 48 kilometers. The distance is 48 kilometers. After getting the time, we have to multiply by 60 to convert this into minutes. Now, remember or just note that this time that will be calculated there will be in terms of hours. Now for us to get the time in minutes, we have to multiply by 60 because 1 hour is equal to 60 minutes. That's why we have multiplied it by 60 and get 72 minutes. The time taken by B, is 48 divided by 30 times 60. So the same analogy here applies. So that will be 96 minutes. The distance is still the same, 48. Back to the question, see how 30 has come up. 30 is 30 here. This 30 there. That is the speed of B. So once again, note that this speed is in kilometers per hour. So we have to multiply by 60 to get the speed to be in minutes. We need these times to be in minutes. Now that B starts earlier, it delays by 10 minutes. So we have to subtract 10 because to factor in the delay, to factor in the 10 minutes that is B is ahead of. So 96 minus 10 is 86. So that taking the the difference, say 86 minus 72, that is 14 minutes. Remember that at the time B is ahead, A is delaying by 10 minutes. So as we're talking about 10 minutes ahead, we are also factoring in the concept of the fact that A is also delaying by 10 minutes. That is the solution to that particular problem. Let us go to the next question. 2 towns A and B are 80 kilometers apart. Juma started cycling from town A to town B at 10 a.m. at an average speed of 40 kilometers per hour. Mutuku started his journey from town B to town A at 10:30 a.m. and traveled by car at an average speed of 60 kilometers per hour. So, it is always important that when you're talking about linear motion, you come up with a sketch. So let us draw a sketch showing the two relative motion. Town A, we have town A and town B, which is 80 kilometers apart. So town A and the town B, and the distance is 80 kilometers apart. Now, Juma started cycling from A to B at 10:30 and the speed of 40 kilometers per hour. So Juma, let me use a different color. Juma, sorry for that. Juma from town A, town B, 10 a.m. and the speed is 40 kilometers per hour. Or let me just write 40 per hour. And then we have the other person called Mutuko started his journey from town B to A at 10:30 and traveled by car at 60 kilometers per hour. So Mutuku was heading in the opposite direction, but he started later, that is 10:30, and the speed is 60 kilometers per hour. Now, having that in mind, you note that Mutuko traveled later, Juma traveled earlier, and these two particular people are moving in the opposite direction. So, are moving in the opposite direction. Now, the distance traveled, since Juma traveled earlier, we can say that the distance that he traveled is equal to x, and the distance that Mutuku traveled is equal to 80 minus x. The distance that Mutuku traveled is 80 minus x. The distance that Juma traveled is x. Now let us go to the solution. The distance, calculate the distance from town A when Juma and Mutuku met. So that is the distances. We have seen the distance Juma traveled is x and that of Mutuku is. Now before they meet, there was a time lapse between the two of 30 minutes. 30 minutes is equal to 1 hour. So 30 minutes is equal to, half an hour is equal to half an hour. So 30 minutes is always equal to half an hour. So before that is also the time difference. Now, also something else to note is that the time taken by Juma is x over 40, since we have said x is the distance between the two. So let us call x the distance apart. The distance separating the two individuals, x apart. So that from time is equal to speed, distance over speed. We can see that the distance is x over 40. The speed of Juma The speed of Juma is 40 kilometers per hour. So x, this x here, divided by 40 kilometers per hour. So x over 40, you get the time. Now the time taken by Mutuku, is this distance here, 80 minus x, divided by the speed, which is 60 kilometers per hour. So here it is 80 minus x over 60 kilometers per hour. So we already let x to be the distance apart, or the distance from A. Now, maybe we can show another relationship here, very important. It is Juma who started earlier, then Mutuku came later, or Mutuku started later. So the time of Juma minus the time of Mutuku is equal to half an hour. These are the times. Let me use TG and the TM to show the time of Juma and the time of M. Using the expressions of the times in terms of H, like we have seen there, we can say this time of Juma minus this time of Mutuku is equal to half. So it's just a matter of getting the difference. But our idea here is to get the value of x. Now after establishing that and doing all this manipulation, it's just about multiplying by 40 both sides, multiplying by 60 both sides, and multiplying by 2, or rather getting the LCM, which is 120. You can do any kind of manipulation you feel like. You can use the LCM, you can multiply by 60 by 40 by 2 both sides, provided that the main idea here is to get the value of x. Now from this question, the value of x is, from this solution, the value of x is 44 kilometers. The answer should be in kilometers because you're talking about kilometers per hour. The time is already in hours, and maybe this is the reason why the time is presented as a half, not 30 minutes. 30 minutes over 60 is equal to a half. So let us go to the next part of the problem. The time of the day when the two met. The time of the day when the two met. So let us go back to the diagram and see when did they meet. The two individuals met somewhere at x distance. Now it is after some time, it is after Juma's time, from 10 a.m. plus Juma's time, the two met. How much time did Juma use? Let us see in the solution. Juma used how much time? 44 kilometers divided by 40. Remember, x, the distance is 44. So the distance traveled by Juma is 44. The speed of Juma is 40. So take that time that Juma started, or the time that Juma took off, plus the time Juma traveled, the distance. If the time is 10 a.m. plus 1 hour 6 minutes. Now let me talk about this briefly talk about this. 44 divided by 60. For us to get that, you have to you get 1 point some decimals. For you to convert those decimals, multiply the decimals times 60 to get 6 minutes. I'm very sure when you can try to verify using a calculator. 44 over 40 will not give you 1.6. So 44 over 40 is 1 point. Let me see, 1 point what over 2 to 1 over 2, 20, 10 is 1 and 1 over 10, or rather it's 1.1. So 1 and say 1 hour, there's a 0.1 times 60, you get 6 minutes. So that is how you convert those, you do that conversion. So 1 hour 6 minutes. So total up 10 a.m. plus 1 hour 6 minutes, you get 11:06 a.m. Next, Kamau started cycling from town A to town B at 10:21 a.m. He met Motuku at the same time as Juma did. Determine Kamau's average speed. Let us go back to the diagram once again. The distance, we are told that Kamau started cycling from A to town B at 10:21 a.m. 10:21 a.m. So Kamau, sorry. So let me draw again. Let us have a neater diagram. So this is from point A to point B. Kamau was heading in that direction before he met Motuko in that direction. So Kamau, the speed of Kamau was the time it took off is 10:21 from point A. So, and he was traveling towards M, and they met at the same time. He met Juma. So that means Kamau had covered X kilometers, where the value of X is 44 kilometers. That is the distance Kamau covered. But you can see that between Juma, let us compare the time of Juma and the time of Kamau. Let's compare the two times. The time of Juma took off at 10 a.m. Kamau took off 10:21. So the time difference is 21 minutes. 21 minutes is the time difference. So we have to get the time difference, or rather the speeds, and after getting the difference in speeds, we can now be able to get the speed, the average speed. Now, in this expression here in the question, Kamau's time is equal to the speed, rather the time of Kamau's time is the time of Juma minus the time of Kamau. since Kamau took 21 minutes. Since he took 21 minutes, the difference in times will be the Kamau's time, the difference in speeds will be 3/4 hours. That is the difference in speed. Or rather, we can call it relative speed. And why are we subtracting? We are subtracting because Kamau is moving in the same direction as Juma. So the relative speed is the difference in the two speeds. So don't forget that 44/40, it is the speed of Juma, and 21/60 is the speed of Kamau. Why are we dividing by 60? We are dividing by 60 because we want this to be in hours. 21 is minutes, so 21/60 in hours. And therefore, because we want speed, that was just time difference. Relative time. This is relative time. Relative time relates to particular bodies, that is relative time. We are taking the difference because they are moving in the same direction. So that is relative time. So relative time is that. Now, the relative time is 3/4 hours. So the speed needed is 44 divided by 3/4. 44 is the distance x divided by 3/4. And therefore, the speed of Kamau is 58 and 2/3 hours. On to the next, and I think this is the last question. Nairobi and Eldoret are 600 kilometers apart. At 9:20 a.m., a lorry leaves Eldoret for Nairobi at a speed of 60 kilometers per hour. At 10 a.m., a car leaves Eldoret to Nairobi at a speed of 120 kilometers per hour. After 20 minutes of travel, the car develops a mechanical problem which takes 20 minutes to repair. The car then proceeds with the journey at the same speed. So this is a relative motion relating bodies that are moving in the same direction. So let us have a sketch to illustrate the motions. Now we have two terms. We are going to use E for Eldoret and N for Nairobi, the capital city of Kenya. And we are told the distance is 600 kilometers apart. 600 kilometers apart. The lorry 9:20 a.m. lorry leaves at 60 kilometers per hour, leaves Eldoret for Nairobi. So we have the lorry at 60 kilometers per hour. He leaves that at 9:20 a.m. moving in that direction. And then the car, let us see what the car does. At the 10 a.m., a car leaves Eldoret for Nairobi at a speed of 120. So the car leaves Nairobi at 120 kilometers per hour. Now, you just note that at some point there, these two bodies are going to overtake one another towards Nairobi. They are all moving towards Nairobi. Now, after 20 minutes of travel, the car develops a mechanical problem which takes 20 minutes to repair. The car then proceeds with the journey at the same speed. Now let us go to the problems at hand. Calculate the time the lorry arrived in Nairobi. Once again, time is equal to distance over speed. The distance is 600 kilometers and the speed of the lorry is 60 kilometers per hour. That's why we are saying 600 over 60, and the answer is 10 hours. But we are asking, that is the time taken by the lorry from time the lorry to arrive in Nairobi. The lorry arrived at Nairobi which time? The time the lorry started was 9:20 a.m. 9:20 a.m. So we have to add 10 hours to 9:20 a.m. and that is what is happening here. 9:20 to 10 hours. That will be 1920 hours in 24-hour clock system, or 7:20 p.m. in 12-hour clock system. Let us go to part B. Find the time when the car overtakes the lorry. Like we had noted earlier, is that at some point one body will overtake the other, and in most cases, or in every case, the one that the highest speed will overtake the ones that has less speed. So it is the car which will overtake the bus. Here we are going to ask ourselves questions that will help us to reason. We are going to ask ourselves questions that will help us to reason. And these are the questions we are going to ask ourselves. If we let the time to be x after 10 a.m., that is after 10 a.m., we let the time to be x, or rather, we let the time to be x is time. If we let the time to be x, then we have to note this, that the car will require x minus 1 over 3 hours. Now where is 1 over 3 coming from? We are told that the car traveled by, the car's delayed. It delayed at 10 a.m. A car leaves Eldoret 20 km after 20 minutes of travel. So the car develops a mechanical problem. So after 20 minutes of travel, the car will develop mechanical problem. So that's why I'm saying 20 divided by 60, the answer is 1 over 3. The answer is 1 over 3. Now what is x minus 1 over 3? X minus 1 over 3 is the overtaking time. Overtaking time. Is the overtaking. Let me use OT. Overtaking time of the car. Now, remember that when the car is delaying, the lorry is gaining some mileage, so it's going to take 40 minutes more compared to the car. So x minus 40, that is x minus 40 over 60. So you get 2 over 3, and that is where this 2 over 3 is coming from. Once again is this here, x minus 2 over 3 is the overtaking time of the lorry, the time taken by the lorry to be overtaken. The time taken by the lorry to be overtaken is x minus 2 over 3. What is x? X is the time in hours after 10 a.m. After 10 a.m., the time in hours. And then we know that the two bodies will be in motion. One will overtake the other. So x minus 1 over 3 is the overtaking time of the car. X minus 2 over 3 is the overtaking time of the lorry. And now, for them to overtake the other, we have to multiply the overtaking time with the speeds. Now these are the speeds. Distance is equal to speed times time. Now, what are these distances? These are called distance apart. The distance apart must be equal because it is relating the two. Okay, the distance apart must be equal. Now that this is speed and this is time, this is speed and this is time, all of them are distances, must be equal. So the first distance equal to the second distance, which all of them are known as distance apart, and that is how that particular equation is formulated. On to the solving of the solution. It is found out the value of x is 4 over 3. Once again, when you key in the calculator, you will expect to get 1.2. Maybe it is not that way. This is how we convert. Say 4 over 3 is the same as 1 and 1 over 3. So take 1 over 3 times 60. 1 over 3 times 60. You get 20 minutes. So that is 1 hour 20 minutes. But since we are asked about time, we're not asked how long. We are going to say 10 a.m. plus 1 hour 20 minutes, and that becomes 11:20 a.m. On to the next part of this particular problem. Find the distance from Nairobi at the overtaking point. Distance from Nairobi at the overtaking point. Now we are going to take the time. Let us go back. Let us see the time. The time of the lorry. The lorry arrived in Nairobi at 19:20 hours. That is the time the lorry arrived in Nairobi. And then the time they met was 11:20 a.m. The time they met is 11:20 a.m. So the time they met, let's see, this is Nairobi. From where they met, okay, from where they met to Nairobi, from where they met to Nairobi, okay, from where they met to Nairobi, it is going to be the difference in the times. We are using the lorry because we know the time when the lorry arrived in Nairobi. So the distance from Nairobi at the overtaking point. So that will be 11:20 minus 9:20. That is 2 hours. But since we want to find the distance from Nairobi at the overtaking point, once again we are going to use the speed of the lorry. The speed of the lorry is 60. So from distance is equal to speed times time. From that relationship, we see that distance from Nairobi using the lorry is 60 times 2. 60 is the speed of lorry. So 60 times 2 is 120 kilometers. That is the distance from Eldoret. The distance from Eldoret. Why are we using the distance from Eldoret? Because we can be able to know that the distance from Eldoret is the speed. It took 2 hours. Okay, it took 2 hours for the lorry to travel. Okay, from Eldoret to where they meet. It took 2 hours for this particular lorry to travel from Eldoret to the meeting point. Now, from Eldoret to the meeting point, from Eldoret to the meeting point, the distance is the distance we are talking about. From Eldoret to the meeting point, that distance there is the distance from Eldoret to the meeting point is 120 kilometers. That is 60, the speed of the lorry, times 2 hours, the time between Eldoret to the meeting point. That is 120 kilometers. And now the distance from Nairobi to the meeting point, you are going to say 600 minus 120 because the total distance we have seen is 600. So, and the time from the Eldoret to the meeting point is, the overtaking point. It is not the meeting, with the overtaking point is 120. So 600 minus 120 is 480 kilometers. On to the last part of this problem. Calculate how far the lorry was from Eldoret when the car reached Nairobi. Let me read it once again. Calculate how far the lorry was from Eldoret when the car reached Nairobi. So, when the car took how many hours? The car took 600 over 120. That is the time that the car took, which is 5 hours. But the total time taken by the car, remember that the car took 20 minutes, delayed by 20 minutes, and it also delayed by another there was also a delay, 20 minutes, another 20 minutes for repairing, and therefore when you look at the time lapse, time taken by the car, it is 6 hours. All of that, the time taken by the car, factoring in all the, let us go back to the question and see. The car at 10 a.m. So the car traveled 40 minutes later. See, 10 a.m., 9:20. So the car traveled 40 minutes later after the lorry. After 20 minutes of travel, so the car also delayed by 60. So what we are saying here is that These are the two things we are factoring in. Take 10 minus 920, that is 40 minutes. 40 minutes plus the 20 minutes that the car delayed. 20 minutes that the car delayed, that is 60 minutes, 1 hour. 1 hour. 60 minutes or 1 hour. So that's why we say the total time taken by the car is 5 plus 1, which is 6 hours. Now, when the car reached Eldoret, which means it must cover it will cover how much distance? So let us see. Since the car took 6 hours, we go back to the question. How far the lorry? We are asked about the lorry, so we use the speed of the lorry times the time taken by the car to get the distance of the lorry, which is 60 times 6, 360 kilometers. So that's the end of this particular tutorial. Hope to meet you in the next video. Thank you.